So it's the 19th of March. We're almost to spring, people. We can do it. We can do it. Spring starts this week, and I still have a spelling error in my slide here. There. It looks terrible, but we'll call it okay. This is what we really spent yesterday kind of going through. The difference between primary and secondary succession. And in secondary, the big difference is soil. If you've got soil, it's secondary. There was a community there before. Because soil is not dirt, soil is not sand, soil is not bits of rock. Sand is not soil. Did you know that? Soil is minerals, it's bits of rock, and it's also dead bodies. What? Of plants, of insects, of animals. It's organic matter. It's got stuff other than just the minerals in it. It's not just rock. Sand is just minerals. It's just silicon dioxide. It's tiny little rocks. You can't grow plants in pure sand, or very few plants. Soil is a whole different thing. Soil has organic material in it from decomposed living things. Primary succession, you're starting without any of that. It's pure rock, and so there is no soil. So, pioneer species are the first ones who can brave that new environment. And the one that they talked about in the video, they talked about lichen and moss. And that's a lichen right there. And they kind of talked about those like those are the only pioneer species. We do typically refer to a different set of pioneer species in secondary successions. And you've seen pioneer species. Who here has seen a weed growing through a sidewalk? What kind of weeds love to grow through sidewalks? There are a couple of right answers here. Dandelions are really good. Crabgrass is great. There's some little thing that grows in the cracks in our driveway that I go pick out every summer. All those things. Plantain is one of my personal favorites. That's a pioneer too. It's just not a pioneer in a primary succession. Because those pioneers in secondary all require that there be soil. So they're coming up through the pavement, through the crack in the sidewalk, from soil that's underneath that. And, same thing applies to them as to the pioneers in a primary succession. They're fast growing, they're relatively fast reproducing, they can live in kind of imperfect conditions. I think I told you my joke, but I'm going to tell it again. In a primary succession, lichen, of course, is our big pioneer species because it can grow on bare rock. And it's actually a symbiotic organism. It is an algae and a fungus, and we now know also some bacteria because Freddy Fungus took a lichen to Alice algae. But now their relationship is on the rocks. Thank you. And those lichen actually, they secrete acid. It's like they're throwing up on the rock continually and breaking down the rock and making little chunks of minerals. And when they die, their dead bodies start to form soil. It's pretty cool. You don't have to do that in a secondary succession. Crabgrass can come up from the soil underneath the pavement. It can come up in the old farm field. It can come up after a forest fire. As long as there's soil, we're looking at secondary, and we're looking at different pioneer species. So what happens if you just leave it alone? It grows. And eventually you get to what's called a climax community. So climax means like the final thing.
Turning.
Huh?
That's English. That's like turning.
Well, in a story, the climax is like the height of the action. And then you have, everything else is anticlimactic. So the climax is the height of the biological community. And after that, things are kind of stable and established, and it's not really changing. The action's over. The growth of the biological community is over. So the climax community is very different depending on where we're talking about on the globe. And the big things that determine this are temperature, precipitation, and your latitude. So I've got 3 sort of different scenes there. We've got a few maps. So this is Tucson, Arizona. It's 60 miles north of the Mexican border. It's, I don't know, 150 miles, something like that. It's a couple hours from the California coast. Maybe it's more like 200. I've driven not all the way to the coast, but I've driven from Tucson into California. I've driven to LA from there. It's a day trip. I mean, you could get to the coast, you could drive it in a day. And the Climax community in Tucson, Arizona is this. It's pretty. It's beautiful. That's a forest. Does that look like a forest to you? That's what this Ohio farm girl thought when she landed in Tucson at age 19. Thought you said there was a forest here. That's the forest. That is a saguaro forest. I've got a few more pictures. That's actually out in the national park that's on the outskirts of Tucson, Saguaro National Park. When I lived there, it was still a national monument, but it got park status a few years later. So how tall do you think those cactuses are? Those are saguaro cactuses. They only grow in this portion of the world, basically southern Arizona, northern Mexico, a little bit of New Mexico. They stop, they peter out long before you get to California. They don't grow in Baja California. How tall? 50? 70? Those are 50 feet tall. They're crazy tall. Maybe somebody is perfectly invited to fact check me, but 40 to 60? Okay, cool. Hey, thank you. So yeah, 50 feet tall. We'll say 50.
I want to see a man stand.
Oh my gosh, they don't. And this picture's taken over a long range. Now, we have old growth forests here in Ohio. What's an old tree? 150, 300 years. You know, we talk about statehood trees that were here in 1803. Those cactuses don't grow a first side limb till they're 75 years old. So those cactuses that you're seeing with a couple of side limbs are probably well over 100 years old. They are slow growing. They are massive. It is not a shady forest by a long shot, let me tell you. But it's a forest. Gets lots of heat, plenty of light, less than a foot of water per year. So literally less than that much water per year. And most of that happens in about 2 months during the monsoon season. It's a pretty harsh environment. But if you just let your yard go in Tucson, that's what it'll turn into eventually. And then we have Anchorage, Alaska. I'd like to see Alaska. So pretty far north. Anchorage is actually a little bit warmer than a lot of Alaska, and the picture I've got is probably from a little bit inland. But that's a mountain pass in Alaska. That's a forest. Does it look like much of a forest? It's pretty scrubby looking. There are some trees, but those are pretty short. Those trees are not all that tall. It's mostly scrub and brush. Kind of shrubby. That's the Climax community there. There's no shortage of, there's no shortage of light in the summer when you have 20 hours of daylight. There's no shortage of dark in the winter when you have 20 hours of dark. They don't get a whole lot of moisture. They get a lot more than Arizona, and I'd have to look up the exact figures. Interior Alaska, a lot of it comes down as snow. But the climate is fairly dry because cold air doesn't hold a lot of moisture. It doesn't hold it real well. What moisture is there, a lot of it's frozen. There's a permafrost layer. So there's really not a lot of water available to plants. And for a good portion of the year, there's not a whole lot of sunlight available. Both of these have limiting factors. Now, let's talk about Brazil. Brazil, the rainforest. When I was talking about this earlier, Joao walked in to drop off a paper, and I was like, perfect! Okay, so, not all of Brazil looks like this, but in the interior of Brazil, that's rainforest. That is Amazonian rainforest. It's pretty darn dense. No shortage of heat, light, or moisture. That whole little biological community there is holding so much moisture. There's a cloud of mist over the forest because the trees are going, they're breathing out clouds of vapor. There is this mist that forms over it because of evapotranspiration. So the tree is actually putting moisture out into the air. It's amazing. I just heard a whole thing about how the Amazonian rainforest actually affects weather patterns for like a quarter of the globe just because of the moisture that's put out there. It's crazy. So what about us? We've talked about all these exotic places, Alaska and Arizona and Brazil, and here's good old little old us right here in the tri-state area. Sitting here just west of Pennsylvania, just north and slightly west of West Virginia, south of one of the Great Lakes. What's our Climax community? Don't yell it out. Jot it down. Do you think it has a name? So, I mean, we said this is saguaro forest. This is probably boreal, it'd be like boreal scrub forest. This is tropical rainforest. What do we have? Well, maybe we should deal with what it would look like before we deal with what it's called. Does that seem accurate to you? You just let it all go. Is that what you're going to get? Yep. Quit mowing your lawn. Tell your parents you're participating in a long-term ecological experiment. No, I'm sorry, Dad. I can't mow the lawn anymore. You see, I'm allowing a natural biological community to regrow right here in our yard. You don't mind, do you? I didn't think you would. He might mind. She might mind. Somebody might mind. The neighbors might mind. I don't know, but that's what it looks like, right? Now, what do you think it's called? Okay, so it's neither of these, but it does have Eastern in the name. Here's what I'm going to tell you. Well, first I'll give you the sort of plain language name. It is the Eastern mixed deciduous, which I can never spell right, forest. Terrible handwriting. Eastern mixed deciduous forest, sometimes called the Eastern mixed hardwood forest. If you're really fancy, you would call it the Eastern mixed mesophytic forest, but nobody but biologists would do that. The Eastern mixed deciduous forest, here's what I want to tell you. The place that you are from is pretty darn special. So not only are we a hotbed of hellbender biomass, who here has driven to Cleveland? Excellent. So if you go up the turnpike to Cleveland, if you head up 11, get to 80, get to the turnpike, you go right straight through Geauga County, Ohio, and they're very proud of their maple syrup. They have all kinds of maple syrup festivals, which are delicious, and you should definitely attend one. But they have that because in that part of Ohio, their forests are almost all sugar maples and beeches. 2 species dominate their forests. If you go a little bit further west in Ohio, you get into what are called the oak openings, and they're forests that are dominated by oak trees. Very few other species. If you take a square, if you go into Beaver Creek State Park and you take a square the size of this room, you're probably going to find 12 to 15 species of trees in an area like this. And that's pretty common throughout the Eastern mixed hardwood forest. If you go into West Virginia, if you go into central Pennsylvania, you're going to find the same thing. It's an Appalachian thing. It is unlike any other forest on the planet. They do not have forests like that in Europe. They do not have forests like that in Asia. They do not have forests like that in Central America. There is a smaller mix of tree species in pretty much every other forest on the planet. We are special. We got variety. We got cherries, we got red oaks, white oaks, pin oaks, swamp white oaks. We got sugar maples, red maples, silver maples, sycamores. We got shagbark hickory and pignut hickory. We got shadbush, serviceberry. We got flowering dogwood. We got crab apples as a native. We've got really tons of tree species, and that's not common. It's pretty cool. I like our forests. Huh? So now comes the real question. We said earlier that some communities are more resistant to change than others. So this is multiple choice, A, B, C, D. A, of course, is the eastern mixed hardwood forest, should be familiar to you. B is that Alaskan boreal sort of scrub forest. C is the saguaro forests of the Sonoran Desert. And D is the Amazonian rainforest. Which ones do you think? So let's say that I'm feeling ornery and I get a bulldozer and I just drive it through one of these for a couple miles, which I would not do. If I did that, which one of these biological communities do you think would heal itself the fastest? In which one would the evidence of my mischief on a bulldozer disappear the most rapidly? In which one would it take the longest? How long do you think it would take? So rank them in order. Fastest, number 1. Evidence would be gone pretty quickly. Up through, this is going to take a while to get over. It's going to take us a while to get over this, being number 4. I'll pause while you think. I'm glad nobody picked B or C because those are probably tied for 3rd and 4th. So the question is, all of you have A and D as 1 or 2. Which one is going to heal faster? Is anybody too chicken to take a position?
I'm going to say C because it takes.
D is number 1 by a long shot. You run a bulldozer through that, and within 6 months, it'll be hard to tell where the bulldozer was. I mean, you would have to look closely. You would start to see evidence of no big trees in that pathway, but it would be completely filled in with vegetation. That's got a 365-day-a-year growing season. There's never a time when plants are not growing. So our happy little eastern mixed mesophytic forest would probably be number 2. If we ran a bulldozer through that, well, think about how many of you have followed an old road through the woods, on a 4-wheeler, on a horse, on foot. If somebody doesn't drive that, after a couple years, it starts to disappear. You start to get shrubs growing in on the side, trails disappear. And it doesn't take a whole lot for a trail to disappear. It happens, but it'll take a few years. You'll be able to see that trackway for a couple years. By the end of the first growing season, it'll probably be full, with vegetation up to the knees. But even to get shrubby is going to take a few more years. To get trees back in that trackway is going to take a bit longer. Now, B and C. B's got no shortage of sunlight, or C, has no shortage of sunlight. It's got all the sunlight you could possibly want. But there's a very limited supply of water. So the plants that do live there are heavily adapted. Those saguaros have got a thick skin. You can't cut one of those with a little pocket knife because the skin on those suckers, you pretty much need a chainsaw to cut into one of those. Though you should never do that because those are old growth trees and they take a really long time to get that big, so don't waste all their efforts. There's not a whole lot of water, and that limits what can grow there and how many can grow there and how fast stuff can grow. It's a limiting factor. In B, at least through half of the year, there's no limit on sunlight. But there's a limit on temperature. And there is a limit on water because a lot of the water is frozen for a lot of the year. So in both of those situations, you have some limits on water. What does it take for plants to do well? Sunlight and water. Temperature helps because of the water availability. So the more plants you have living in a place, the more resistant it is to change. Higher species richness tends to exist where you've got lots of light and water. Communities that have higher species richness are better able to recover from a disturbance. That's why D does so well. You drive a bulldozer through it in 6 months, you're barely going to see wear. And it all comes back to our game of Jenga. How many pieces are you starting with in that tropical rainforest? Thousands. How many pieces are you starting with in our forest? Probably hundreds in a little tiny area. In the boreal forest, in the saguaro forest, you're starting with fewer species. You're starting with just fewer species. And that means those places tend to have a little bit less diversity. They tend to have lower species richness. They don't come back easily. If you bulldoze, and they talked about, when I lived in Tucson, I mean, when I moved there, I honestly didn't get the forest thing. Like, it took me a while, because like I said, Ohio farm girl moves to Tucson, goes, it's 100 and how much? Oh my God, I'm never coming out of the house. It was 116 the week I moved there. It's terrible. They would, hot.
So that's a great first.
Oh yeah, no, it's a terrible first impression. There were places on the edge of Tucson that had been bulldozed, and it took, I mean, it just didn't recover, period. And they talked about, like, the trees that do live there, like ironwoods. Ironwoods are so called because their wood is so dense it sinks in water. They're incredibly slow growing. An ironwood tree that's just a little bit taller than me might be 150 or 200 years old. You know, they look like a little stump of nothing for 50 years. That means that biological community doesn't recover from damage fast. Everything there is slow growing. It's not getting all that big. It's not that robust, and so they don't recover as fast. Okay, here's the deal. Your test is Thursday. There is a study guide here. You have vocab part C. Tomorrow we're going to do a couple things and wrap up a few more loose ends in preparation for your test on Thursday. Oh, you're a peach, thanks. All I'm going to say is, please, 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 for the love of all that you hold sacred, don't type the questions into Google. Let's talk about this. What's the purpose of a study guide? To actually, you know what? It's not even that. You know what the purpose of a study guide is? I'm glad you said that.
From your brain.
The purpose of a study guide is to remind you of the information that you need to look back at. Oh. So go to your notes, go to the videos, go to your vocab, use that. So that's it. I will shut up and leave you to work with the radio on.